be back. Well, you remember last time we were talking about memory, and I tried to give you a general overview of the way memory operates, and I told you that it was kind of like perception. It was an interpretive process. And then toward the end of the lecture, I began talking about a different kind of memory system, which we call short-term memory. Now, you all have short-term memory, and I told you why it was important. For example, to understand spoken language, if you notice, when I talk, one word follows another in sequence. So for you to understand the meaning of a sentence, it requires you to remember the early part of the sentence in order to, and wait until you get to the end in order to understand the sentence as a whole. So you have to have a mechanism to maintain information in pretty much a literal form over very brief intervals of time. And there are three questions that we can ask as psychologists about the nature of this memory system. The first is, how do you represent information? And I'll come back to that in a second. How quickly is information from short-term memory forgotten? We talked about that last time a little bit. And finally, we can address what the capacity of this system is. And by capacity, when you're a memory person, you mean how much information can you actually store in that system. So I want to go through each of these, talk about some relevant evidence, and we'll do some demonstrations to kind of back up what I have to say. Well, let's start by talk about that question of how we represent information in short-term memory. Now, if you think about it, you're all utilizing short-term memory right now as you listen to me talk. Now, I want you to think about what's going on inside your head right now. All of you have a kind of conscious awareness of yourself and your surroundings. And short-term memory is often synonymous with what we mean by consciousness. So think about what's going on inside your head right now. If I were to ask you to tell me what kind of information is there right now in your conscious awareness, what would you say? I mean, are there images up there? What is the representational format of thought? You can answer this question yourself by simply looking inside your head and analyzing it. What's going on right now? In some cases, obviously nothing from the looks on your face, but if you try to introspect, what's going on up there? Well, it turns out that the answer is what's going on up there in your conscious mind right now, which is synonymous with this short-term memory system we've been talking about, is a voice. You have a voice inside your head right now, and it's talking to you. It's saying, what is this guy talking about? I can't believe I took this class. Whatever it's saying, I want to get out of here, spring break. Whatever it's doing right now, it's happening in the form of a voice. How do we know that? Well, actually, the last time I was in here, way back when I first introduced psychology to you, I talked about one experiment that gave us evidence for its voice. That was an experiment where I told you that people were asked to read short passages that had been written by people who either spoke very quickly or who spoke very slowly. So I familiarize you with a person speaking, and there's somebody that speaks quickly or somebody that speaks slowly, and then I give you a short passage and I say, this was written by the person that you just heard talking. And then I time how long it takes you to read that passage. It turns out that you read the passage a lot faster if you think the person that wrote it speaks quickly. So it's like you hear their voice inside your head. When you read an email from your mom, do you hear her voice in your head when you're reading it? Well, another kind of evidence that we can use is we can look at the kinds of errors that you make when I ask you to recall information from short-term memory. So let's do a little experiment here. I'm going to read you a set of letters, and then I want you to recall them back to me. Okay? Here we go. Ready? B, A, R, J, L, X. Recall. So if I look at your recall for a short list of letters like that, I can focus on cases where you make a mistake, where you intrude a letter that wasn't actually on the list. And I can ask myself the question, what does the nature of that error look like? And there are two possibilities, two obvious possibilities. One is that you could intrude a letter that looks like the letter that was actually presented. So if what you do inside your head is form an image of those letters, then if I gave you a letter like O, I would expect you to mistake it with a letter that looks like O, maybe Q. On the other hand, if what you represent inside your head is a voice, then when you make a mistake, I would expect you to substitute a letter that sounds like the letter. So if I gave you, for instance, C, instead of saying O, you might say T, because C and T sound very much alike. There's been a lot of evidence, a lot of research on this question, and overwhelmingly, when you are remembering stuff from short-term memory, the errors that you make are acoustic. They're auditory, which is exactly what you would expect if you represented information in terms of some kind of an inner voice. There are lots of experiments, as I said. Here's another little. I was actually doing an experiment like this myself that involved counting. And I was having people count backward from 100, 199, 98, 97, and so on. And I noticed that they made certain kinds of errors, even when they were counting by writing down. They missed double-digit numbers that sounded similar, like 99, 88, 77. So they'd go 100, 99, 98, 97, 96, 95, 94, 93, 92, 91, 89, 87, 86, 85, 84. They'd go over the ones that sounded similar even when they were writing them down. And again, that's because when you count, you're doing it in a voice inside your head. Well, anyway, I was running this experiment, and one of the participants looked at me and said, "Oh, that's like a game we play called I've Got 11 Fingers. You ever played that game? Let me show it to you. Let me count the number of fingers that I have. 6'1", 6'2", 6'3", 6'4", 6'5", 6'7", 6'8", 6'9", 6'10", 6'11". I'll do it again. 6'1", 6'2", 6'3", 6'4", 6'5", 6'7", 6'8", 6'9", 6'10", 6'11". 10, 9, 8, 7, 6, and 5 is 11. You've got 11 fingers. There's a guy in the back going. Obviously, what's going on there is that you are representing information in terms of the sound, and things that are similar get passed by. So this is all evidence that you represent stuff internally in terms of a voice. Does that make sense to you? Well, let me ask you one more question before we move on. Whose voice is that? So you have a voice inside your head. I just argued that. You nodded. You didn't look particularly upset when I said that. You've got a voice inside your head. It's saying things to you right now. Well, whose voice is that? Well, how do you know whose voice it is? You assume it's yours, but on what basis do you make that assumption? You ever heard yourself on a tape recorder? What's the very first thing that people say when they hear themselves on a tape recorder? Well, that's not me. Doesn't sound like you, does it? So how do you know whose voice that is? Well, you've heard of schizophrenia, right? You know it's a psychotic disorder, axis 1 of the DSM-4. A lot of times people with schizophrenia have hallucinations, and often those hallucinations take the form of an auditory hallucination. So they hear voices. You ever wondered what it might be like to hear a voice? Well, it turns out that if you do a brain scan of people with schizophrenia when they are hearing auditory hallucinations, the area that lights up in their brain is the same area that lights up when you talk to yourself. So that little voice inside your head that's going on right now is exactly the same thing that's happening to somebody with schizophrenia. The only difference is that you are arrogant enough to assume that that little voice is you. They, on the other hand, have lost that attribution and are simply assuming that that little voice is maybe the neighbor's dog Sam or the devil. Well, you can think about that for a while. Now, information in short-term memory is represented in terms of a voice. Why is that? Why would nature have given you a little voice inside your head? Well, it turns out that the reason why you have a voice inside your head and the reason why you represent things in consciousness in terms of a voice is because short-term memory plays an important role in the production and comprehension of spoken language. So the way you represent information in short-term memory is synonymous with your primary mode of communication. So you might be wondering, what about somebody who is deaf or hearing impaired? Do they have an inner voice? And the answer is, it turns out that whether or not a deaf or hearing impaired person has an inner voice depends on whether they know how to speak or not. So if their dominant mode of communication is not auditory spoken language, but rather sign language, then if you look at the errors that people that communicate through sign language make in a short-term memory experiment, they make signing errors. So they will substitute items that have similar signs, not similar sounds. So the way you represent information in short-term memory is synonymous with your primary mode of communication. Do dogs have an inner bark? Maybe. All right, let's move on to the second question. Well, actually, I said that you have an inner voice, but you do also have an inner eye. So you can form visual images inside your head. You can do that right now. Suppose I asked you to imagine an ant standing next to an elephant. Could you form a visual image of an ant standing next to an elephant? That's a visual image. And in fact, there's some evidence to suggest that visual images are kind of like actual visual pictures that you might see. Let me give you an example. Suppose I were to draw a boat like this, little boat here, okay? Can you see that? Now, what I want you to do is I want you to form a visual image of what I've got up there on the board inside your head. Close your eyes. Form a visual image of that boat. Close your eyes. That's what these are. Close them. Form a visual image of that boat. Now I want you to focus on the bow, the front of the boat. And as quickly as you can, I want you to tell me what's on the flag at the edge of the boat, end of the boat. What is it? A triangle and some squirrely lines? Okay. It turns out that if I do an experiment like that and I measure how long it takes you to tell me what's on that little flag, it's called reaction time. If I plot reaction time as a function of the length of the boat, so for other people, they get a shorter boat, other people get a longer boat, and I plot reaction time as a function of the length of the boat in your image. So I'm going to plot reaction time, how long it takes for you to get the correct answer, as a function of the boat length. That is a linear function. So the longer the boat is in your head, the longer it takes you to scan from one point on the boat to the other. That's exactly what you would expect if you were literally looking at a picture of a boat. So that suggests that, in fact, inside your head, you are capable of forming things that look like visual images. How many of you can form visual images of, say, a good friend inside your head? Raise your hand if you can do that. For the record, most people are raising their hand right now. All right, well, you might remember last time I told you that memory was very reconstructive, and that oftentimes you remember things that aren't actually true. Well, this is also correct about your visual image that you just did. In fact, the visual images that you form inside your head are very inaccurate, even though they seem to you to be very accurate. So how many of you, for instance, can form a visual image of a penny? Raise your hand high if you can form a visual image of a penny. Raise your hand high. How many are confident that you can form a visual image of a penny inside your head? You've seen it a million times. Raise your hand high. All right, what I want you to do, this is a brief little exercise, but get out a piece of paper, and on that paper I want you to draw what's on the front of that penny. Just try doing it for 1 minute. Okay, so let me give you a hint. When you're drawing the picture of a penny, there is a president on the front of the penny. Don't get out and look at one. Come on. This is a memory thing. You draw a circle. And in the circle, there is a president. Raise your hand if you know who the president is on a penny. Raise your hand high. A lot of you. Okay. Abraham Lincoln is the president on a penny. You got his image in your head? All right, now, raise your hand if you're looking directly down at a picture of a penny. Let me just, before I do this, I want to make absolutely certain you've all seen a penny before. You've seen a penny. Now, raise your hand if you believe that Abraham Lincoln is facing, as you look down on the penny, is facing to the left. Raise your hand high if you think he's facing to the left. Don't be shy. Raise your hand high. How many of you think that Abraham Lincoln is facing to the right? Raise your hand high. Okay, this is, by the way, raising your hand involves actually moving your hand up. This is not raising your hand. This is raising your hand. Let's practice. Okay, everybody, hand up, hand down. Okay, how many of you think that President Lincoln is facing to the left? Raise your hand high. High. Look around the room. Put your hand down. How many of you think that President Lincoln is facing to the right? Raise your hand high. How could this be, folks? Oh, I forgot to ask, how many of you think he's facing forward? Raise your hand. Okay. How can this be? If we actually conduct the experiment in the laboratory under controlled circumstances, and we ask people to do this experiment, we get about half the people think Lincoln's facing to the left, and half the people that think's facing to the right. It's a chance. How can that be? You all were convinced you could see the image of the penny in your head. We're only talking about facing to the left or the right. I'm not talking about little tiny things like what's written at the top. I know you don't know that. So zoom into your penny in your head. You've got the image. Zoom in there and read to me silently. Read to me what's written at the top. Can you do it? You can't do it. In fact, it's actually in God we trust, I believe. I could ask you where the bottom line is you have no idea what the front of a penny looks like. You think you do, so you have a belief that you can form a visual image of a penny, but actually you don't. You have no idea what a penny looks like. And this has been demonstrated repeatedly. In fact, I don't even have to have you recall it. I can do this. I can present you with a bunch of alternative pennies. And I can say, pick out the penny. You've seen one a million times. Pick out the penny that's the correct U.S. currency. You can't do it. We've done this in the laboratory many times, and you're essentially at chance. You can't do it. So yes, you have some sort of thing going on up there that you think is an image. You can't do it for your boyfriend either. So if I were to ask you questions and ask you to form a visual image of your boyfriend or your girlfriend, you can't do that either. It's an illusion, folks. You think you have this, but in fact you don't, which corresponds to what I was talking about previously. Okay, let's move on. So let's just review what I've told you. The only difference between you and somebody with schizophrenia is an illusory belief that that little thing going on inside your head is you. Actually, I'm kidding, okay? If you're worried. That little voice inside your head, it is absolutely correct for you to be attributing that to yourself. Although the evidence is weak, but it's correct for you, it's normal for you to be doing that. Second, you can form representations in your head, an inner eye, but they don't really bear much resemblance to what reality actually is, which is intriguing. Okay, let's go to how quickly is information forgotten. We did this last time. Raise your hand if you can remember the 3 letters that I gave you at the end of class last time. All right, I'm going to ask you to yell them out on 3. Ready? 1, 2, 3.
XPR.
Yeah, and you're never going to forget that, are you? Well, I said you wouldn't be able to remember those 3 letters over 10 or 15 seconds, right? But I'm going to do the experiment a little bit differently today. instead of letting you continue to think about the letters during the 10 seconds, I'm going to prevent you from thinking about the letters. So when I gave you XBR, you repeated them over and over again in your head, didn't you? You went XBR, 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 XBR. That's called rehearsal. Think about that term, rehearsal. What does that sound like? Re-hear. Again, it's that inner voice. Re-hearsal. It's an inner voice. I've got to see how long you can remember 3 letters when you're not thinking about them. Okay, so let's try it again. Ready? Now, I'm going to give you 3 letters, and I don't want you to think about it. I want you to not think about them until I ask you to recall. Ready? Here we go. Don't think about it. Here we go. Ready? T, C, W. Don't think about it. Recall. I think you cheated. All right, let's try it a different way. I want you to count backwards by 3s from a 3-digit number that I'm going to yell out. Let's practice. Suppose I wanted you to count backward aloud from 100 by 3s. I want you to do that now for me so that everybody that's going to be watching this lecture on tape can hear you. Okay? Here we go. 100. 88, 85, 82, 79, 76, 73, 70, 67, 64, 61, 58, 55. Come on. Go. Those of you watching this on tape, don't try this at home because you need experience to be able to count backwards by 3s. It's one of the things that you develop if you're a memory researcher. The ability to count backward by 3s very, very quickly. Let's try another one. 465, 462. All right. I'm going to give you 3 letters. Then I'm going to give you a 3-digit number. I want you to count backwards by 3s aloud as quickly as you can. Are you ready? Here we go. MBQ, 300, 297, 294. Recall. Ready. TMH, 193, 190, 187. Recall. If you actually do this experiment under controlled circumstances, when I prevent you from thinking about information that's just been presented to you, you forget it in 10 to 15 seconds. So information that's represented in consciousness, in short-term memory, if I prevent you from thinking about it by having you engage in an alternative task, you forget it very quickly in 10 to 15 seconds. Now you notice it said 1 to 2 seconds. That'll be clearer a little bit later. Okay, let's move on. What's the capacity of short-term memory? We talk about a concept called memory span. Memory span is the number of items that can be recalled from short-term memory in order on half of the tested memory trials. I'm going to read you lists of letters, and I want you to recall them back to me. You ready? YMG, RWQH, BRJLXP recall. Ready? AURBKFSRE recall. Ready? NQHGWBJ recall. Well, if you do this, you notice that the short ones were easy and the long ones were hard. If you do this experiment and you look at memory span, it turns out to be somewhere in the vicinity of 7 plus or minus 2 items. So if I do 7 items, you're okay. But if I start doing 8 or 9, you fall apart. 7 plus or minus 2. So it's a range between, say, 5 and 9 will be most people's memory span. How long are telephone numbers without the area code? 7. Do you think that's an accident? You think it's just out of the blue that some engineer decided telephone numbers should be 7 digits long? No. It's because that's about the capacity of short-term memory, is 7 plus or minus 2 items. Let's do another one. Ready? THISLECTURISBORING recall. How many got that one? Well, for some of you, your memory span went from 7 plus or minus 2 way up. And that's because you probably recognized that the letters that I were giving you formed words. THISLECTURE. ISBORING. In that particular case, you're able to remember a lot more than 7 plus or minus 2. And the reason is because you are able to chunk the information. Chunking the information into smaller units makes it a lot easier for you to remember. THIS is this. And so you really only need to remember this lecture is boring, 4. So it's 7 plus or minus 2 chunks of information. It's whatever you can rehearse inside your head. You can say this lecture is boring, this lecture is boring, this lecture is boring over and over again. That's only a chunk of 4. If I made it so that there were 7 chunks or 8 chunks, you'd start having problems again. So the capacity is really 7 plus or minus 2 chunks of information. And it's not even really that. And I'm going to give you a metaphor to kind of carry with you, and then I want to start talking about long-term memory. You can sort of think about how you remember over the short term, like juggling. So you know when you juggle, you have a capacity. So a person that's juggling, there's so many balls that they can hold in the air at any given time. And the capacity, some people can do 4, some people can do 7. The capacity is a trade-off between gravity, which is pushing the ball down to the ground, and your skill in throwing it back up again. It's the trade-off between how quickly you can throw it back up again and how quickly gravity pushes it down that creates your capacity. So you can think about that metaphor to explain the capacity of short-term memory. You have forces inside your head that are causing that information to be forgotten very rapidly. And the only way you can prevent that information from being lost is to rehearse it. So information's forgetting and you're rehearsing. So forgetting is like gravity and rehearsing is like throwing the ball up. And your capacity is going to be equal to how much stuff you can say to yourself before the first one hits the ground. And so turns out that it's about what you can say to yourself in 1 to 2 seconds. So you can say about 7 plus or minus 2 things to yourself in 1 to 2 seconds. So the true forgetting rate is really what you can say to yourself in 1 to 2 seconds. That's a metaphor. Okay. Let me move on. I would have more to say about that normally, but I've only got 2 lectures, so I've got to move on. Well, let's talk a little bit about long-term memory. You already know that all of this stuff is reconstructive, but there are techniques that we can use to help you remember things. Before I do that, though, I'll give you a couple techniques. You should understand that there are 3 types of information that we talk about in long-term memory. There's episodic memory, semantic memory, and procedural memory. Episodic memory is memory for personal episodes in your life. So, do you remember your first kiss, for instance? You have a flashbulb memory for that? It's probably wrong, but you have a feeling that you remember when your first kiss was. Raise your hand. All right, let's go easier. How many of you remember what you had for breakfast this morning? Raise your hand. We're still stretching limits here, but that's an episodic memory. It's the ability to recover a particular episode from your life. That is different from semantic memory. Semantic memory is knowledge. So how many of you know what the square root of 9 is? Well, if you remember the square root of 9, you are not going back to a prior episode in your life. That's something you just know, like the capital of Indiana. You know that, but you're not remembering any particular episode in your life. You just know it. So episodic memories are memories that are autobiographical. And they're sort of different from knowledge in that they're specific to a particular place and time. And they're also tinged with kind of warmth and intimacy, as William James said it. So, you think about, you have emotions associated with autobiographical memories, like your first kiss. You don't for the square root of 9. The third type of memory that you have is what we call a procedural memory. And a procedural memory is your ability to know how to do things. So you know how to ride a bike, for instance. You know how to tie your shoes. You know how to walk. But could you actually explain to me that knowledge? One of the interesting characteristics of procedural memory is that you have no insight into it. So you can all tie your shoes, but could you explain to somebody how to tie their shoe? Or walk? Think about it. Pretty difficult. Well, you grab the laces, move them over, or just walk. How do you walk? Well, you put one foot in front of the other. Okay. And then you take the other one. It's very difficult. This is the reason why coaching is so hard. Because you cannot explain to somebody, like you can in episodic memory, how to do something. It's not accessible to consciousness. So if I wanted to explain how to swing a golf club to you, think about doing that. You can't do it. We don't have accessible to us procedural. So what does a typical coach do when they're teaching golf or something? They show you. They say, okay, this is what you do. They show you a swing. So procedural memories are different from episodic and semantic, and they're not accessible to consciousness, which makes the study of memory kind of difficult, because you have no insight into how you do it. Here's another list for you. Ready? QRLP, recall. How did you do that? How did you do that? You took information that vanished. It was no longer there in the world. It's gone. What were those again? Those are gone. Those are not part of the physical universe anymore, but yet you're able to reproduce them. How do you do that? Explain to me how you do that. Well, like, I don't know, it's just like they're just there. Think about it. How do you do it? You have no idea. The reason why you don't have any idea is because it's procedural, which makes it very difficult for us, the people who want to study memory, because we don't have any insight into it either. Okay, what's the best way to remember? Usually I spend 2 weeks on memory when I'm teaching this class myself, so I only have 2 lectures, so I'm not going to be able to give you a lot on the best way to remember. You can read about some of it in the book. Let me just briefly talk about 2 things which I think are really important. First, almost all memory enhancement techniques. So if you were to go to the bookstore and look up books on how to improve your memory, you'd find books, or you could pay a lot of money for tapes, mega memory, and so on. Here's improve your memory in 20 days, triple your memory. They're all based on the same thing. They're based on techniques that were developed by the Greeks thousands of years ago. And they're all based on mental imagery. The most famous example of one of these mnemonic techniques is one called the method of loci. And this was based on a Greek who was at a banquet. And he was eating with a bunch of people at a table, a big banquet with entertainment. And he got called away by someone. And he went outside briefly for just a minute. While he was outside, there was an earthquake and the building collapsed, killing everybody inside. The bodies were so mangled that there was no way for anyone to identify who was there and who wasn't. And so he remembered who was there by going back inside his head and imagining that he was sitting around the table. He formed a visual image of everybody at the table, and he was able to then read off the names based on accessing that image. And that insight became the basis for a technique called the method of loci. Loci meaning location. And the way the method of loci works is that you simply form a visual image of a location, like your house. And the information that you want to remember, you form a visual image of information at different locations in the house. Okay, that's called the method of loci. Visual imagery, mnemonic techniques, very useful in terms of establishing long-term memories. A second thing that I want to talk about that you probably don't know about, and you're not going to like it, is that one of the most effective ways for you to learn material for a course, so you want to remember what's been presented to you in a course, the most effective way to do that is to practice retrieving that information. What most of you do when you study is simply read the book. So you just go over it and over it a bunch of times. Oh, I'll just read the book one more time. That turns out to be an extremely ineffective way of learning. A much more effective way for you to learn is to actually practice remembering. So read the book, close it, and then practice remembering. Write down what was in the book. It's really a remarkable effect. Let me just show you a couple of experiments. This was an experiment where students were asked to remember things from a science textbook. So this is not that different from what you have to do. In one group, they were given the opportunity to study the material twice. So they were given the book, and they were allowed to study it twice for 7-minute periods. In a second group, they were allowed to study it for 7 minutes, and then the book was closed, and they had to write down what they remembered. So one group got 2 7-minute study opportunities, and the second group only got 1, but then they practiced remembering. And they were tested either 5 minutes, 2 days, or 1 week later. These are the results of that experiment. If you look at how well people remember things after 5 minutes, then studying it twice is a little bit better. But if you look at how well they remember it after 2 days, there's a whopping change. The people that practiced remembering remembered it substantially better than the people that studied it. And if you look after a week, it's the same kind of an effect. Here's another experiment that shows the same thing. I'm telling you something critical here because this is the way you should be studying. This was an experiment where one group read the passage 4 times. The second read it 3 times and was tested once. And the third group read it only once and remembered it 3 times. Now, if you actually look at the number of exposures that people got to the material in these conditions, the people that studied it 4 times read the material 14.2 times. The people that tested it 3 times only read it 3 times. Who do you think would remember it better? Somebody that studied it 14 times or somebody that studied it 3 times? If you ask students, they think that the people that studied it 14 times are going to remember it better. Makes sense, right? Here are the results. If you look at their memory after 5 minutes, yes, the people that studied it 14 times remember it better. But if you look at it after a week, it completely reverses. So if you want to remember stuff for a test, don't repeatedly read it. That's not an effective way to study. What you should do is practice remembering. If you wanted to get good at the piano, what would you do? You'd practice. If you want to get good at remembering, what do? Practice. You don't study. That would be like sitting and trying to get good at the piano by reading the sheet music over and over again. That's not the good way to study. You become an expert in memory by practicing. So that's the way you should study. Okay.